Okay, so we've gone over two of our three types of problems that you'll see with trig identities. Moving on from that first sheet, the practice problems were pretty easy. I'm sorry I didn't spend a lot of time writing out all of those problems really neatly, but I don't think it's worth your time to really spend time working on those problems. I'm guessing that this sheet and the next sheet that we're going to go over are probably the two sheets that you had the most difficulty with, but I also would bet that they're probably most likely what your quiz is going to look like, or your reassessment. So I'm going to kind of take some more time going over these because I think that'll be more worth your while. So looking at this sheet, these questions are really focusing again on that third type of problem, which is going to be proofs with trig identities that an equation with two sides, that both sides of that equation are equal, and you kind of manipulate both sides using your identities. So going through what that's going to look like with this first problem here. Again, it's just kind of really trial and error, and familiarity with your identities is going to make a huge difference. It's going to make a big difference because if you can kind of recognize the patterns that'll arise when you're doing these problems, so that you know kind of off the top of your head what you're going to have to sub in instead of trying to mull through your notes. I know you have a reference table. It's going to be a huge help to just have those things right there for you. But if you can kind of already know your bearings with various patterns before you start, that's just going to save you that much more time, and you're going to be, that much more comfortable with them. So looking at our first problem here, we have 1 minus cosine theta times 1 plus 1 over cosine theta is equal to tangent theta times sine theta. So it's kind of a lot to digest. So let's just kind of focus on one side. So right now I'm just going to work with the left side here because that has a lot more going on. And the first step I'm going to take is just to distribute our problems, or our two sets of parentheses here. So you get 1 plus 1 over cosine theta minus cosine theta minus cosine theta over cosine theta, and that's still equal to tangent theta times sine theta. So now that we have our terms all written out here, we can do some simplifying first of all, because we know that this fraction right here, cosine theta over cosine theta, is going to turn into 1 over 1. So that's going to be 1 plus 1 over cosine theta minus cosine theta minus 1. And because we know that this is going to be a 1, we know that adding 1 and subtracting 1, that these will cancel out altogether. So we'll be left with 1 over cosine theta minus cosine theta equal to tangent theta times sine of theta. So I'm just kind of I skipped over some algebra there. Again, that cosine theta over cosine theta would turn into a 1 because you're subtracting a 1, and you also had a 1 over here at the start of the problem. Those two would cancel, and you're left with what you have right here. So looking as far as what we can do now, when we're still trying to simplify what's on the left side of our equation here, you have a subtraction sign here, but it's between two terms that don't have a common denominator. So the best thing to do there is to find a common denominator so you can combine them to simplify this side into one term. So to do that, you have 1 over cosine theta minus cosine theta over 1. And what you're going to do here is multiply by cosine theta over cosine theta, because that's equal to 1, and that'll get you cosine theta in your denominator. So when you multiply that out, I'm going to bring this up here to work with. When you multiply this out, you're left with 1 over cosine theta minus cosine squared theta, because you're multiplying two cosines together, over cosine theta. That's equal to your tan theta times sine theta. So now we can combine these terms because they have common denominators. So 1 minus cosine squared theta over cosine theta is equal to tan theta times sine theta. So looking at this now, we can kind of refer back to our trig identities because we're familiar with these. We can recognize the pattern that we have a 1 minus cosine squared theta right here, and we know that that equals sine squared theta. So we have a sine squared theta over cosine theta. And with that, we've really kind of reduced this left side as much as possible. So I'm going to look over to this right side here and see what we can do over here. We see a tangent, and we know that a tangent can also be written as sine over cosine. And again, we're still multiplying that by our sine value. So when we multiply this out, we're going to have our sine squared theta over cosine theta, and that's going to be equal on this side to sine times sine, which is sine squared theta over cosine theta. So I'm just going to box this because they match and check it, because that solves our problem. That gives us our, oh, I am so sorry if that was completely all off screen. I bet that was. Trying to get used to this zooming thing. Not the app, but like zooming in with my phone. Here we go. So sorry about that. But you can see that we combined our terms up here to 1 minus cosine squared over cosine. That gave us our sine squared theta, because we know that 1 minus cosine squared theta is sine squared theta from our Pythagorean identity. And we worked with our right side because we know that tangent is sine over cosine. When we multiplied our sine over cosine by our sine, we got our sine squared theta over cosine, and those two matched. And that's the goal. So problem 1 done. Yay! Okay, so moving on to question 2. We have that we want to prove 1 plus sine of 2 theta equal to sine of theta plus cosine of theta squared. So because we have that squared, this side kind of looks a little bit more complicated than this side. So I'm just going to kind of copy that side down, copy the left side down, and start working over here. So I'm going to write out our sine squared, our sine theta plus cosine theta times sine theta plus cosine theta. And now that we have those written out, we can distribute. So our left side stays the same. We distribute and get sine squared theta. And then because we know that, when you distribute like terms, we know that this is going to give us sine theta times cosine theta, and that our two middle terms here are also going to give us sine theta times cosine theta, so we can just write 2 sine theta cosine theta, because we'll get that from our outer and our inner terms, our 2 sine theta cosine theta, and then our 2 right terms. We're going to get cosine squared theta. Okay, so now we can kind of combine terms. So now that we have this kind of bunch of terms on the right side here, this is where you know, once again, your familiarity with the identities themselves is going to help. Because I have experience when I'm looking at this, I can say, oh, well, we have a sine squared theta and a cosine squared theta. And if I look back to my identities, I know that a sine squared theta and a cosine squared theta equal 1 for our Pythagorean identity. So when I'm looking back here as to what I can do, I'm going to copy down our left side there, but I'm going to put our sine squared theta and our cosine squared theta next to each other, and I'm going to put them in parentheses just to kind of accentuate that those two are grouped together, because I know that those can form an identity that'll help me later on. Looking up here, we're then left with plus 2 sine theta, cosine theta, which looking back here, kind of see what we can do with those. We see that 2 sine theta, cosine theta is actually another identity. It's our sine double angle identity. So we know that that value, that set of terms will equal sine of 2 theta. So looking down here, I'm going to keep copying down my left side because there's nothing we can really do over there. We just figured out that our sine squared theta plus cosine squared theta is going to equal 1. So this whole big term that we have in parentheses here is going to equal 1. And then that 2 times sine theta cosine theta from our double angle identities is going to give us sine of 2 theta. And when you look and check back to your left side, that's what we were going for. So there you go. A lot more simple than our first problem, but that's just kind of how these things go. It depends on what problem you're working with and what identities you can use as far as how complicated and how long they're going to take you to figure out. Alright, so looking towards our third problem here, we have 4 minus cosine of 2 theta plus 5 sine theta is equal to 2 sine squared theta plus 5 sine theta plus 3. So the first thing I see here is that we have a plus 5 sine theta on either side. And so I'm just going to subtract that right out because there's no need to have extra terms when we're trying to get things simplified. So we're left with 4 minus cosine 2 theta is equal to 2 sine squared theta plus 3. And so I'm looking at what we have left here, and when I'm looking at what I want to substitute in, I'm kind of checking back and forth to see, you know, what I have and what I can do. So I know I have a cosine 2 theta, and when I look at what we could do with that, I see that the only real conversion that we could do with a cosine 2 theta would be to get more terms, because you'd be converting that cosine 2 theta into one of these 3 options here on the right, which both have more terms. We don't want to get more terms, so I'm going to see what else we can do here. We also have a 2 sine squared theta, and when I look at that, we have a 2 sine squared theta right here in this this cosine double angle identity. So I'm going to copy that identity over so we can work with it here. So we have cosine of 2 theta. Can you see that? Cosine 2 theta is equal to 1 minus 2 sine squared theta. And you'll notice the reason I really chose to work with this right side here is because 2 sine squared theta is part of an identity that includes cosine of 2 theta, which we have on the left side here. So then I know if we can manipulate this side somehow to get to this cosine 2 theta value, then we might be able to get to our, to prove that these 2 sides are equal. So looking here, we have our cosine 2 theta is equal to 1 minus 2 sine squared theta. I want to try to get that 2 sine squared theta by itself to see what value I would substitute in its place. I'm going to subtract a 1 from either side. And I'm left with cosine 2 theta minus 1 is equal to negative 2 sine squared theta. And I have a positive here, but I have a negative. I have a positive in my original equation, but I have a negative here. So I'm just going to multiply both sides by negative 1. And when you multiply this side, there's 2 terms, so you have to remember to multiply both terms by negative 1, not just one term. So the negative 1 becomes a positive 1. I'm going to bring that out front, and then our positive cosine 2 theta becomes a negative cosine 2 theta, so I'm going to leave that there. And then our negative 2 sine squared theta becomes a positive 2 sine squared theta. So now I know that this term here can be subbed in for a positive 2 sine squared theta, and that's exactly what I'm going to do in our equation over here. So we have on the left side still 4 minus cosine of 2 theta, but now I'm going to sub in 1 minus cosine of 2 theta into our right side, and that plus 3 is going to stay there. Combining like terms, I see that I have a 1 and a 3 that can be added, and when I do that, you'll see that our 2 sides match. So there you go. That's the front side of the sheet. I'm also going to do page 2. I just want to do it in a separate video so that it's easier to upload to YouTube. So I'll get back to you with the second page.